I'm Kendall Roberg from Burbank High School, and today we're going to learn about solving systems of linear equations using substitution. Now if we start over here, each of these is a linear equation. We know that because if we graphed them, they would graph a line. Now when you combine them, we call this a system of linear equations. And our goal today is going to be to solve that system of linear equations. Let's start by looking at the red equation. I see that if I subtract 4y from both sides, I'm left with x equals 2 minus 4y. What that means is anywhere I see x, I can now substitute in 2 minus 4y. Let's do that in the first equation, the black equation. Instead of writing x, I'm going to write 2 minus 4y. Now what's neat about this equation is it no longer has x in it. We can now solve for y. To do that, we're going to need to distribute the 2. So we have 4 minus 8y plus 5y equals 7. By combining like terms, the negative 8 and the 5y, I'm left with 4 minus 3y equals 7. Subtracting 4 from both sides leaves me with negative 3y equals 3. And finally, dividing by negative 3, I can see the solution for y. That is, y equals negative 1. And I'm going to rewrite this negative 1 in a different color. The reason is, whenever I see y now, I can simply write the number negative 1. So let's go back to our red equation. Instead of x plus 4y equals 2, I can say x plus 4 times negative 1 equals 2. Solving this equation for x, I'll see that, well, let's see, 4 times negative 1 is negative 4. Adding 4 to both sides will turn the 2 into a 6. So I'm going to see that x equals 6. What this means is that at the point on the graph, 6, negative 1, these two linear equations will meet. This system of linear equations has one solution. Now let's look at this second example. In this case, I see it will be pretty easy to solve for y in the red equation by adding 2x to both sides. I can see now that y equals negative 5 plus 2x. Now, whenever I see y, I can write this blue binomial, negative 5 plus 2x. So let's substitute that in to the original equation. So I now have 6x minus 3 times, substitute in for y, equals 15. Once again, using the distributive property, I have 6x plus 15 minus 6x equals 15. Now in this situation, something interesting happens when we combine like terms. 6x minus 6x leaves us with 0x. So they actually cancel each other out, and I'm left with 15 equals 15. Now 15 always equals 15. So this system of linear equations actually has infinitely many solutions. We could confirm this by graphing these two linear equations, and we would actually see that they graph the same line. Now finally, in our third example, let's solve for y again in the red equation. We can do that by adding 3x to each side. So we can see we can now substitute y for 7 plus 3x. When we do that substitution into the black equation, we get once again using the distributive property, we're left with 6x minus 14 minus 6x equals 5. Now, combining like terms, we'll have the 6x and the negative 6x cancel each other out. And we're left with negative 14 equals 5. Now, negative 14 never equals 5. And in this system of linear equations, we actually have no solution. We could confirm this by graphing these two linear equations. We would actually see that these two lines are parallel. They never intersect, and therefore the system of linear equations has no solution.